we have to integrate root 2 root of 1 plus sin x dx. The answer is given as minus 4 cos of ax plus b plus c. We have to find the value of a and b. Options have been given. We'll integrate in a normal manner. We'll apply the half angle formulas for 1 plus sin x. The integral will convert to root 2 integral of cos of x by 2 plus sine of x by 2 the whole square. This is the formula for sine 1 plus sin x, and please note this is whole under the root dx. Square and the root will cancel off. Integral will convert to root of cos x by 2 plus sine x by 2 dx. Now since we have we have a root 2 here, what I am doing is I am multiplying and dividing by root 2 inside. We'll get cos x by 2 upon root 2 plus sine x by 2 upon root 2 dx. Once we have this, root 2 is a constant, comes out, becomes 2 integral of cos x by 2 upon root 2 sin x by 2 upon root 2. Both these 1 by root 2 and 1 by root 2, I am writing it as sin pi by 4 and cos pi by 4 respectively, so that I can write this entire term as sine of x plus pi by 4 dx. Integrating for sine, our answer would be minus 2 cos of pi by 4 plus x by 2 the whole divided by 1 by 2 plus c. Final answer minus 2 cos x by 2 plus pi by 4 plus c. Just interchanging these two values, comparing, I'll get the value of a as half and b as pi by 4, which is our option A. Integral of 5 tan x upon tan x minus 2 dx equal to x plus a ln of mod sin x minus 2 cos x plus k. When I am using this word ln, this implies it is log to the base e. Please note this is ln e is always ln of any term. Ln x is same as log x to the base e. Okay. To solve this, I am converting this tan x in terms of sine and cos. So this becomes 5 sin x upon cos x upon sin x upon cos x minus 2 dx. The integral will be written as 5 sin x upon sin x minus 2 cos x dx. Now observe, this is of the type sine cosine type A, where we had delete it out. This is of the type sine cosine type D, in which we compare this entire integral with a sin x plus b cos x upon c sin x plus d cos x. We'll compare it with this type, apply the standard method which we follow over there, and the integral will reach out to integral of 1 dx plus 2 times integral of cos x plus 2 sin x upon sin x minus 2 cos x dx. Applying the formula, it would become x plus 2 ln, that is log mod sin x minus 2 cos x plus c, and therefore comparing with the given question, the value of a turns out to be 2. Integral of x square minus 1 upon x cube root of 2x raised to 4 minus 2x square plus 1. We are observing all the options contain the denominator. The only difference is with the denominator of all the options. Let's see how do we manage this. At the first step, we will just divide this x cube to these two terms in the numerator. We'll get this as 1 upon x minus 1 upon x cube to the root of 2x raised to 4 minus 2x square plus 1 dx. In the next step, from this denominator, I'm going to take x raised to 4 common. What we'll get is integral of 1 upon x minus 1 upon x cube divided by x square with the root of 2 minus 2 upon x square plus 1 upon x raised to 4. This x square again will be split into these two terms. We'll get the integral as 1 upon x cube minus 1 upon x raised to 5, the whole division by root of 2 minus 2 upon x square plus 1 upon x raised to 4. Now I'm going to substitute this term in the denominator as t. Substitute 2 minus 2 upon x square plus 1 upon x raised to 4 equal to t. Differentiating with respect to x, our term would be 4 upon x cube minus 4 upon x raised to 5, which is equal to dt by dx, and I'm simplifying this as 1 upon x cube minus 1 upon x raised to 5 dx is equal to dt upon 4. Integral will be dt upon 4 divided by root of t. 1 by 4 turns outside. Integral of root t will be 2 root t plus c, and our answer would be root 2 minus 2 upon x square plus 1 upon x raised to 4 the whole upon 2, and simplifying we will get it as root of 2x raised to 4 minus 2x square plus 1 upon 2x square plus c, which is option number D. Integral of f of x dx is equal to g of x. Then we have to find the integral of f inverse of x dx. The options are as follows: g inverse x, x f inverse x minus g of f inverse x, x f inverse x minus g inverse x, and f inverse x. To find this integral, we'll write integral of f inverse x into 1 dx. Applying the formula of u into v, what we'll get is x f inverse of x minus integral of x derivative of f inverse of x dx. Now for simplification purpose, I am saying that let f inverse of x be equal to t. As usual, if you are making a substitution, we are differentiating it. So I can say that d dx of f inverse x is equal to dt by dx. At the same time, since f inverse x is equal to t, I can say that x is equal to f of t. Utilizing these two values in this part, my integral will become x f inverse of x minus integral of, observe this x has now become f of t, and derivative of f inverse x, which is dt by dx, we'll just get dt because the dx with this dx will cancel off. I can now state integral is x f inverse of x minus g of t. This is because we have been given that integral of f of x is equal to g of x. So instead of letter x, we have the variable t, and the value of t is f inverse x. So the final answer is x f inverse x minus g of f inverse of x, which is option B. If integral of 1 plus cos 4x upon cot x minus tan x is equal to k cos 4x plus c, then we have to find the value of k. This one will be using the half angle formulas. 1 plus cos 4x will be written as 2 cos square 2x. Writing cot x as cos x upon sin x and tan x as sin x upon cos x, what we'll get is cos square x minus sin square x into sin x cos x. Observe this, cos square x minus sin square x will turn out to be cos 2x into sin x cos x dx. One term goes off. What we have now is integral of cos 2x and 2 sin x cos x. This entire term will become sin 2x dx. To solve this, we'll multiply, divide by 2, 1 upon 2 integral of 2 sin 2x cos 2x dx, which will become half integral of sin 4x dx. Final answer minus cos 4x upon 8 plus c. Therefore, k equals minus 1 by 8, which is option B. Integral of under the root of e raised to x minus 1 dx. We have 4 options. What we are going to do in this is e raised to x minus 1, I am writing it as t square so that the root can cancel it off. Differentiating, e raised to x is equal to 2t dt by dx, and therefore dx is equal to 2t dt upon e raised to x. And please note, this e raised to x, I am going to write it as t square plus 1. Therefore, dx equals 2t dt upon t square plus 1. Integral will now convert to root of t square into 2t dt upon t square plus 1. 2 is a constant, comes out. Root of t square is t, and with this t, this will become t square dt upon t square plus 1. Simplifying, we'll be adding and subtracting 1. Splitting the terms, I get 2 integral of 1 dt minus integral of 1 upon t square plus 1 dt. Integrating and substituting the value of t, will get 2 times under the root of e raised to x minus 1 minus tan inverse of under the root of e raised to x minus 1 plus c, which is our option A. We have been given I is equal to integral of e raised to x upon e raised to 4x plus e raised to 2x plus 1, and j as an integral of e raised to minus x, e raised to minus 4x plus e raised to minus 2x plus 1 dx. Then for some arbitrary constant, we have to find the value of j minus I, and we have the options given. So let's begin with j minus I. With j minus I, I'll have integral of e raised to minus x upon e raised to minus 4x plus e raised to minus 2x plus 1 minus integral of e raised to x upon e raised to 4x plus e raised to 2x plus 1 dx. Now obviously we find that these two terms are almost identical except for that minus sign. Using laws of indices, what we'll get is e raised to minus x into e raised to 4x upon 1 plus e raised to 2x plus e raised to 4x minus integral of e raised to x upon e raised to 4x plus e raised to 2x plus 1. Now since the denominator is the same, I can write this as integral of e raised to 3x minus e raised to x upon e raised to 4x plus e raised to 2x plus 1 dx. Substituting e raised to x equal to t, differentiating after this, we'll get e raised to x dx is equal to dt. Integral will now convert to t square minus 1 upon t raised to 4 plus t square plus 1 dt. Observe what we have done here is this e raised to 3x minus 1 has been written as e raised to 2x minus 1 into e raised to x dx, so that this term has become our dt in this step. After this, I am dividing the numerator and denominator by t square. 1 minus 1 upon t square plus 1 plus 1 upon t square dt. Now, after this step, we will now substitute t plus 1 upon t as a different term. Substitute t plus 1 upon t equal to a term, say z. Differentiating with respect to t, 1 minus 1 upon t square is equal to dz by dt. 1 minus 1 upon t square dt is equal to dz. Now the integral will convert to this entire term will now become dz divided by, we have t square plus 1 by t square, which I am writing it as t plus 1 upon t the whole square minus 1, which now converts to dz upon z square minus 1. Applying the formula for CTS type B, CTS basically, the formula for 1 upon x square minus a square, our answer would be 1 upon 2 log mod z minus 1 upon z plus 1 plus c. Resubstituting the value of t, integral of log integral of half of log mod, instead of z I am going to write t plus 1 upon t minus 1 upon t plus 1 upon t plus 1 plus c, and now instead of t we are going to substitute e raised to x, which was half of log mod e raised to x plus 1 upon e raised to x minus 1 upon e raised to x plus 1 upon e raised to x plus 1. Simplifying, we'll get half log mod e raised to 2x plus 1 minus e raised to x upon e raised to x plus 1 plus e raised to x plus c, which in our option is option number C. Integral of cos x plus x sin x upon x square plus x cos x. The options are as follows. Now, what we do at first step is I'm going to divide the numerator and the denominator by x square. So my integral will convert to cos x plus x sin x the whole upon x square divided by 1 plus cos x upon x. Now we'll substitute the denominator equal to t. Substitute 1 plus cos x upon x equal to t. Differentiate with respect to x. In this part, we'll be applying the formula of u upon v. And after applying the formula of u by v, our answer would turn out to be minus of x sin x plus cos x the whole upon x square equals dt by dx. Now if you observe, we have the same term as our numerator except for that minus, and therefore x sin x plus cos x the whole upon x square dx, we'll write it as minus dt. Integral will now convert to simply minus integral of dt upon t, which is equal to minus log mod x x plus cos x the whole upon x plus c. We see that there is no option which matches the term, and there are no options with a negative sign. We apply the laws of logarithm and write the same term as log mod x upon x plus cos x plus c, which now matches our option B. In equals integral of x raised to n e raised to cx with respect to x for n more than equal to 1. We have to find the value of Cin plus n minus 1 equals any one of these options. Observe the n's have the behavior with these x's. We'll begin with the given integral of x raised to n e raised to cx dx. We'll apply the formula of u into v and follow the rule of Liat. We have the algebraic and the exponential term with us, which is already in the order. Applying u into v, I'll get in as x raised to n e raised to cx upon c minus integral of n x raised to n minus 1 e raised to cx upon c dx. Taking the n and the c outside the integral, I'll get my in as x raised to n e raised to cx upon c. N and c are constant, term will turn out, and I'll get the integral as x raised to n minus 1 e raised to cx dx. Now when we observe this term is nothing but in minus 1. So in is equal to x raised to n e raised to cx upon c minus in minus 1 upon c. Denominator is the same. Shifting the terms, we get Cin plus n minus 1 equals x raised to n into e raised to cx, which matches our option A. F of x equals sine square pi x upon 1 plus pi raised to x. You have to find the integral of f of x plus f of minus x, and the options are as follows. What we do is, we have been given f of x already. We'll first find this f of minus x. F of minus x will become sine of pi minus x the whole square upon 1 plus pi raised to minus x. Simplifying f of minus x as minus sine of pi x the whole square upon 1 plus 1 upon pi raised to x. And therefore f of minus x is equal to sine square pi x into pi raised to x upon 1 plus pi raised to x. Once we have this term, our integral is f of x plus f of minus x dx. Simplifying, the integral will become sine square pi x upon 1 plus pi raised to x plus sine square pi x upon 1 plus pi raised to x into pi raised to x. Taking this 1 plus pi raised to x as the LCM, we can take sine square pi x common. We find this will become sine square pi x upon 1 plus pi raised to x into 1 plus pi raised to x dx. These two terms cancel off. We have the integral of sine square pi x, which can be integrated as 1 minus cos 2 pi x upon 2 dx. 1 by 2 comes out. We integrate 1 and then cos 2 pi x. Our answer will turn out to be x upon 2 minus sine 2 pi x upon 4 pi plus c, which is our option D. Integral of x plus 1 upon x inside the brackets 1 plus x e raised to x the whole square dx. Now, when I'm simplifying this term, I would like you to put a quick look on all the options which we have. We observe that there is an e raised to x in the numerator in all the cases, and when I'll be substituting 1 plus x e raised to x, I would like to have this e raised to x term in the numerator and the denominator. These two things, the option and the substitution, gives me a rough idea about this adjustment. We are going to substitute, as I told you, 1 plus x e raised to x equal to t. On differentiation, I'll get 1 plus x into e raised to x equal to dt by dx, which is now forming my numerator. Therefore, integral equals, this term becomes dt. In the denominator, I have x e raised to x. This x e raised to x, I am writing it as t minus 1. And 1 plus x e raised to x will become t square. Now this integral is converting to the partial fraction category. In the partial fraction, it's of the second category of repetitive linear. By solving the partial fraction, of the category repetitive linear and solving that entire term, I will get the integral as 1 upon t minus 1 dt minus integral of 1 upon t dt minus integral of 1 upon t square dt. On integrating, my final answer would be log mod x e raised to x upon 1 plus x e raised to x plus 1 upon 1 plus x e raised to x plus c, which is my option A. Integral of cube root of x multiplied by 7th root of 1 plus cube root of x raised to 4. Writing all the terms according to the laws of indices. So what we observe is this is like x raised to 1 upon 3. This entire term will be written as 1 plus x raised to 4 upon 3, the whole raised to 1 upon 7 dx. I am now taking this term as t. Substitute 1 plus x raised to 4 upon 3 equals t. Differentiating 4 upon 3 x raised to 1 upon 3 equals dt by dx. And therefore, the integral will now be written as this, and this term together will give me dt with a constant of 3 upon 4 outside, and this term is t raised to 1 upon 7. On integrating t raised to 1 upon 7, my final answer will turn out to be 3 upon 4 t raised to 8 upon 7 divided by 8 upon 7 plus c, which is 21 upon 32, 1 plus x raised to 4 by 3 raised to 8 by 7 plus c, which matches with our option number A. Integral of 1 plus x minus x raised to minus 1 e raised to x plus x raised to minus 1 dx, and the options which follow. When I'm starting with the solution, what I'm doing is I'm keeping the x terms with the e and I'm separating this one. So the integral will now look like integral of e raised to x plus x inverse plus x minus x inverse e raised to x plus x raised to minus 1 dx. Now if you observe, if I take my f of x as e raised to x plus x raised to minus 1, and if we differentiate this term, we'll get e raised to x plus x raised to minus 1 into 1 minus x raised to minus 2. So this is our function, and the derivative is the same term with 1 minus x squared. Now to get this term, I'm going to take x common from this second integral and write this as xe and write this term as our f of x. So integral is e raised to x plus x raised to minus 1 dx plus integral of x 1 minus x raised to minus 2 e raised to x plus x raised to minus 1 dx. Now as we discussed, this entire term will become my f dash of x, and this term I'll write it as f of x. So the question converts to, this is integral of f of x plus integral of x into f dash of x dx. Applying the formula of u into v. On application of formula of u into v, this will become integral of f of x dx, and this u into v will generate x integral of f dash of x dx minus integral of f dash of x dx. Solving this, it will become integral of f of x dx plus x integral of f dash of x, with the integral will become f of x minus integral of f of x dx. So integral of f of x dx cancels. My answer of the question becomes x into f of x, where my f of x is nothing but x e raised to x plus x raised to minus 1 plus c, which is our option D. F of 3x minus 4 upon 3x plus 4 is equal to x plus 2. Question is about integral of f of x, and the options are as follows. Now, what we do in this is, we say let y equals 3x minus 4 upon 3x plus 4. This term is where I'm trying to solve this function. On applying componendo dividendo, I'll get y plus 1 upon y minus 1 equals minus 3x upon 4. On solving this, I'll get the value of x equals 4y plus 4 upon 3 minus 3y. Now, I have been given that f of 3x minus 4 upon 3x plus 4 is equal to x plus 2. Therefore, I am now going to state that my f of y equals 4y plus 4 upon 3 minus 3y plus 2. What I am simply doing is, in place of x, I am substituting its value, and in place of 3x minus 4, I am substituting the value of y. On simplification, I'll get my f of y equals 10 minus 2y upon 3 into 1 minus y. Now, to integrate this, what I am simply doing is, I'll be writing this term as f of y equals 8 plus 2 minus 2y upon 3 into 1 minus y. Splitting the terms, I am writing my f of y as 8 upon 3 into 1 minus y plus 2 minus 2y upon 3 into 1 minus y. Integrating in terms of x, integral of f of x dx will become integral of 8 upon 3 1 minus x dx plus 2 upon 3 integral of 1 minus y with 1 minus x upon 1 minus x dx. This term will cancel off. 8 upon 3 is a constant. My answer would be 8 upon 3 log mod 1 minus x upon minus 1 plus 2x upon 3 plus c, which matches with our option number B. Integral of 1 upon sin x plus 4 into sin x minus 1 to be written in the form of a upon tan x by 2 minus 1 plus b into tan inverse of f of x plus c. Our question is asking us to find a, b and f of x. So let's write down our integral. Our integral is 1 upon sin x plus 4 into sin x minus 1 dx. Now, just for solving this, what am I doing is, I am replacing sin x by t. Please note, I am strictly using the word replacing and not substituting. This will now shift to our partial fraction of the fourth category. If you observe, we have 1 upon t plus 4 into t minus 1, which will be equal to a upon t plus 4 plus b upon t minus 1. And on solving this entire partial fraction, what we'll get is 1 upon t plus 4 into t minus 1 equals a into t minus 1 plus b into t plus 4 upon t plus 4 into t minus 1. Simplifying, 1 equals a into t minus 1 plus b into t plus 4. Now to get a, we put t equals minus 4, so 1 is equal to a into minus 5, and therefore a equals minus 1 upon 5. Similarly, to get b, we'll put t equals 1 is equal to b into 5, and b will become 1 upon 5, and the entire integral will look something like this: 1 by 5 integral of sin x plus 4 minus sin x minus 1 upon sin x plus 4 into sin x minus 5 and splitting the terms with that partial fraction thing, I'll get 1 upon 5 integral of 1 upon sin x minus 1 minus 1 upon 5 integral of 1 upon sin x plus 4. Now, both these integrals are of the category sine cosine A. On solving that entire equation, my answer will be 2 upon 5 into 1 upon tan of x by 2 minus 1 minus 2 upon 5 root 15 tan inverse of 40 plus 1 upon root 15 plus c, which is our option number D, which matches it entirely. We have 2 by 5 minus 2 by 5 root 15, and instead of t we have tan x by 2. So our answer is option D. Yeah. Integral of 1 upon 1 plus cos a cos x. Observe, cos a is to be treated as a constant, and with that logic, this sum falls into our category of sine cosine A. Following the method of sine cosine A, my integral will reach to 2 dt upon 1 plus t square upon 1 plus cos A into 1 minus t square upon 1 plus t square. Simplifying, my integral will convert to 2 dt into 1 plus t square plus cos A into 1 minus t square. Simplifying, integral of 2 dt upon 1 plus cos A plus 1 minus cos A t square. I'm clubbing the t square terms together and the constant terms together. Now observe, 1 plus cos A and 1 minus cos A. We are applying the half angle formula respectively in both the places. I'll get this as 2 cos square A by 2 plus 2 sin square A by 2. Simplifying the terms, we are cancelling of the 2's. I'll get integral of dt upon cos square A by 2 plus sin square A by 2 t square, dividing by sin square A by 2, so I'm taking that sin square A by 2 constant outside so that the t square has a coefficient of 1. So this becomes t square, and cos square upon sin square will give me cot square A by 2. Applying the formula of 1 upon x square plus a square, I'll get the answer as 2 upon sine a tan inverse of tan x upon 2 upon cot of a upon 2 plus c, which matches with our option number B. Integral of root of x square plus 1 upon x raised to 4 of log of x square plus 1 minus 2 log x dx. These are our possible options. Let's simplify. In this term, inside this logarithmic term, we can write that entire bracket as x square plus 1 upon x square. Looking at this pattern, our next step is decided. What am I doing is, I'm taking x square common from the numerator. I get x root of 1 plus 1 upon x square, x raised to 4, and inside the bracket we get this as 1 plus 1 upon x square dx. We have a clear-cut substitution, and cancelling this x raised to 4 with x, I'll get this as root of 1 plus 1 upon x square upon x cube log of 1 plus 1 upon x square dx. I am now substituting 1 plus 1 upon x square as t square. On differentiation, I'll get minus 2 upon x cube equals 2t dt by dx. The 2 and the 2 will cancel off, and therefore dx upon x cube is equal to minus t dt. Using the substitution, integral of the root of t square log of t square and the dx upon x cube will be my minus t dt, which is minus of root of t square is t, and this t will give me t square. Applying the laws of logarithm, this becomes 2 log t dt. Integral of minus 2 integral of t square log t. Now this is of the category u into v, not in the order of Liat, restructuring it as log t into t square dt. Of the Liat term, I have the logarithmic and the algebraic term with me. Applying u into v, I'll get minus 2 of the whole bracket log t into t cube upon 3 minus integral of 1 by t into t cube upon 3 dt. Simplifying, minus 2 integral of t cube log t upon 3 minus t cube upon 9 plus c. Taking t cube upon 3 common, I'll get minus 2 t cube upon 3 log t minus 1 by 3 plus c. I observe at this step, none of my option have a negative sign outside. So, I'm taking the negative inside. I'll get it as t cube upon 3, 1 by 3 minus log t plus c. Now, comparing with the options, I have 1 by 3 and a minus here. And we have a term of 2 by 3, 1 plus x raised to 3 by 2, the way we want it. Now resubstituting the term of t cube, observe that my t square was 1 plus 1 upon x square, and which implies my t cube would be 1 plus 1 upon x square raised to 3 by 2. My answer will now become 2 by 3, 1 plus 1 upon x square raised to 3 by 2 into 1 upon 3 minus log of 1 plus 1 upon x square raised to 1 by 2 plus c. Again comparing with the options, I have none of the terms with log of 1 plus x square raised to half. So I take this half down, 2 by 3, 1 plus 1 upon x square raised to 3 by 2, 1 by 3 minus 1 by 2 log of 1 plus 1 by x square. Taking the 2 inside, I'll get my answer as 1 by 3, 1 plus 1 upon x square raised to 3 by 2 into 2 by 3 minus log of 1 plus 1 upon x square plus c. Now we can compare. This is nothing but our option B. Which will now be as our option B, which we have derived. Integrating e raised to x square plus 1 upon x plus 1 the whole square dx with these following options. Of course, it would be of the category e raised to x f of x plus f dash of x. We'll try to restructure the numerator with this denominator of x plus 1 the whole square. What are we doing is, this x square plus 1, I'll be writing it as x square minus 1 plus 2 upon x plus 1 the whole square. After this step, we'll split the denominator. What we'll get is x square minus 1 upon x plus 1 the whole square plus 2 upon x plus 1 the whole square dx. Talking about this x square minus 1, we are writing that as x minus 1 into x plus 1 and simplifying it as 1 upon x minus 1 upon x plus 1, and the remaining term is 2 upon x plus 1 the whole square. Now comparing with integral of e raised to x f of x plus f dash of x, where my f of x would be x minus 1 upon x plus 1, and f dash of x, after we apply the formula of u upon v, will give us the answer as 2 upon x plus 1 the whole square. Therefore our final answer e raised to x f of x plus c, that is e raised to x into x minus 1 upon x plus 1 plus c, which is our option A. Integral of cot inverse of 1 minus x plus x square dx. These are the options which are a bit too long. Let's see how do we manage this integral. We'll write this integral as tan inverse of 1 upon 1 minus x plus x square. Simplifying, tan inverse of 1 upon 1 minus, I'm taking the x common, so I'll get this as 1 minus x dx. Now looking at this denominator, we are going to adjust the 1 in the numerator as 1 minus x plus x upon 1 minus x into 1 minus x, where this 1 minus x will be treated as one entire term. Now observe, this becomes the formula of tan inverse of x plus y upon 1 minus xy. So our integral will convert to integral of tan inverse of 1 minus x plus integral of tan inverse of x dx. Let's write this as I is equal to I1 plus I2. Coming to I1 is integral of tan inverse of 1 minus x dx. we'll be integrating this with the help of u into v rule by writing tan inverse 1 minus x as tan inverse x minus 1 tan inverse of 1 minus x into 1 dx, applying the formula of u into v dx. After simplification, my final answer would be x tan inverse of 1 minus x plus half log mod 1 plus 1 minus x the whole square minus tan inverse of 1 minus x plus c1. Similarly, for I2, the integral of tan inverse of x dx, we'll write this integral as tan inverse of x into 1 dx. After applying the rule of u into v dx, our answer will be x tan inverse of x minus half log mod 1 plus x square plus c2. Combining the values of c1 and c2, we find that our option C matches the best out of it. So our answer is option C. In equals integral of natural log of x to the power of n, that is log x to the base e to the power of n. Then we have to find the value of in plus n in minus 1. To solve this, what we simply do is integral of log x raised to n dx. We again write this as log x raised to n into 1 dx. We'll apply the formula of u into v. Our answer would be log x raised to n into x minus integral of n log x raised to n minus 1 into 1 upon x and integral of 1 dx. Simplifying, we'll get this as log x raised to n into x minus integral of n log x raised to n minus 1 upon x into integral of 1, which is x dx. X and x will cancel off. Log x raised to n into x minus n is a constant, comes out, integral of log x raised to n minus 1 dx. Observe, my in was log x raised to n, and here I get integral of log x raised to n minus 1, and hence in is equal to x log x raised to n minus n, and this term can now be written as in minus 1. Taking the minus n on the other side, I'll get in plus n minus 1 equals x log x raised to n, which matches with our option C. Integral of 1 upon x square 1 plus x raised to 5 whole raised to 4 by 5. What we'll simply do is, out of this term, I am taking x raised to 5 common, so it becomes x square into x raised to 4 inside the bracket 1 upon x raised to 5 plus 1 the whole raised to 4 by 5. Simplifying, I'll get it as integral of x raised to 6 1 plus 1 upon x raised to 5 raised to 4 by 5. Taking this term as t, 1 plus 1 upon x raised to 5 equals t. Differentiating with respect to x, what we'll get is minus 5 upon x raised to 6 equals dt by dx. Therefore, dx upon x raised to 6 is equal to minus dt upon 5. Our integral will convert to integral of 1 upon t raised to 4 by 5. After completing the integral, our final answer would be minus 1 plus x raised to 5 raised to 1 upon 5 upon x plus c. Integral of dx upon x square 1 plus x raised to 5 raised to 4 by 5. We have these options where 1 plus x raised to 5 is prominent. Let's see what do we do. We'll begin with taking common. We have dx upon x square 1 plus x raised to 5 the whole raised to 4 by 5. I'm taking x raised to 5 common out of this term. What I'll get is x square into x raised to 4 1 upon x raised to 5 plus 1 the whole raised to 4 by 5. Simplifying dx, I'm writing these two terms together as x raised to 6 1 plus 1 upon x raised to 5 the whole raised to 4 by 5. I'm substituting 1 plus 1 upon x raised to 5 equals t. Differentiating minus 5 upon x raised to 6 equals dt by dx, and therefore dx upon x raised to 6 equals minus dt upon 5. Continuing with the integral will become minus 1 upon 5 integral of 1 upon t raised to 4 upon 5 dt. After the integral, my answer would be minus 1 plus x raised to 5 the whole raised to 1 upon 5 upon x plus c, which matches with our option number C. Integral of x raised to x log of ex to the base e, that is natural log of ex. Our options are x raised to x plus c, x log x plus c, log x raised to x plus c, and x raised to log x plus c. What we do is, at the first step, I'm simplifying this term of log of ex. X raised to x log e plus log x dx. Log e is 1, so we get it as 1 plus log x dx. To simplify further, we'll substitute x raised to x equals t. Now observe, this is of the category variable raised to variable. So we take log on both sides. What we get is x log x equals log t. Differentiating, I'll get 1 plus log x by taking a formula of u into v on the left hand side, and on the right hand side I'll get it as 1 by t dt by dx, and therefore 1 plus log x dx is equal to dt upon t. So this term becomes my dt by t. So in my integral, this term is my dt upon t, and my x raised to x is the t itself. T and t cancels off. Integral of 1 dt, which is nothing but t plus c. Our answer x raised to x plus c, which is our option A. If integral of e raised to x f of x minus f dash of x dx is phi of x, the question says find e raised to x f of x dx with these as our option: phi of x plus e raised to x f of x, phi of x minus e raised to x f of x, phi of x plus e raised to x f of x upon 2, half of phi of x plus e raised to x f dash of x. Now, what we'll do is, looking at this pattern, we also know that integral of e raised to x f of x plus f dash of x, a well-known identity as e raised to x f of x. Also, e raised to x f of x minus f dash of x in this case is said to be phi of x. What I'm going to do is we'll add these two equations. So what I'll finally get is 2 times integral of e raised to x f of x dx is equal to e raised to x f of x plus phi of x. Taking the 2 on the other side, integral of e raised to x f of x dx is equal to e raised to x f of x plus phi of x the whole upon 2. Integral of sec x dx upon root of sine of 2x plus a plus sine a, and our options are as follows. We observe there is a sec a and a root 2 here, and all these terms are almost identical containing a tan x. Let's see what do we do. In the denominator, I am applying the formula of sin c plus sin d, which is equal to 2 sin c plus d by 2 into cos c minus d by 2, and we will reach to the step of sec x upon root of 2 sine of x plus a into cos x dx. In the next step, I am multiplying the numerator and denominator by 1 upon cos x. So the integral will become sec x upon cos x, the whole division by 1 upon cos x in the root of 2 sine x plus a cos x. Sec x upon cos x will be written as sec square x, and the cos x which is outside the root when goes inside becomes the square of that term, and what we will get is 2 sine of x plus a upon cos x dx. Taking the root 2 outside, which I can see in some of my options, I am taking 1 upon root 2 outside. I will get integral of sec square x upon root of sine of x plus a will be expanding as sine a cos b plus cos a sine b the whole upon cos x. Splitting the denominator, 1 upon root 2 integral of sec square x upon root of tan x cos a plus sine a dx. Now in the next step, I am taking the entire denominator as t, that is substituting tan x cos a plus sine a equals t. And to be more precise, let's take this as t square so that the root and the term cancels off. Differentiating, what I'll get is cos a sec square x is equal to 2t dt by dx. Therefore, sec square dx will be equal to 2t dt upon cos a. Continuing with the integrals, my integral will now convert to 1 upon root 2 integral of, instead of this sec square x dx, I am going to write it as 2t dt upon cos a, and this entire term will generate a t. Cancelling the t, 1 upon root 2 cos a is outside the integral, the 2 jumps out, and now I am left with integral of 1 dt, which is nothing but root 2 sec a into t plus c, and resubstituting the value of t, so this is root 2 sec a brackets root of tan x cos A plus sin A plus C, which is nothing but our option C. Integral of dx upon 2x minus 7 root of x square minus 7x plus 12. My option all of them with second verse and with the term of 2x minus 7. Solution. What we are going to do in this sum is I'm multiplying and dividing by 2. Root of x square minus 7x plus 12. This 2 I'm taking inside the root. 2 dx into 2x minus 7 into the root of 4x square minus 28x plus 48. Now we observe this is the square of 2x. This is 2 into 7 into 4x. I'll try to complete the square in this space. Applying the CTS method, this is 2x minus 7. This term is root of 4x square minus 28x. I'm writing the 48 as 49 minus 1. By doing this becomes 2 dx upon 2x minus 7 upon root of 2x minus 7 the whole square minus 1. Now if you if we observe, this is the formula of the integral of 1 upon x root of x square minus 1, whose answer is second verse x. So 2 is outside. My integral is of second verse of 2x minus 7, and I am dividing by the coefficient of x plus c. 2 and 2 cancels off. We have second verse of 2x minus 7 plus c, which is option P. Integral of cos 8x minus cos 7x dx upon 1 plus 2 cos 5x. Options: sin 3x by 3 minus sin 2x by 2 plus c, sin 3x upon 3 plus sin 2x upon 2 plus c, sin 2x by 2 minus sin 3x upon 3 plus c, cos 3x upon 3 minus cos 2x by 2 plus c. Coming to this term of cos 8x minus cos 7x upon 1 plus 2 cos 5x, what we are going to do in this case is we are going to multiply and divide by 2 sin 5x upon 2 sin 5x. Observe the effect in the denominator. I'll get it as 2 sin 5x plus 2 into 2, which will be 4 sin 5x cos 5x, and in the numerator I'll have 2 cos 8x sin 5x minus 2 cos 7x sin 5x. In the numerator I am applying the formula of 2 cos A sin B, which is sin of A plus B minus sin of A minus B in both the cases. What we'll get is sin 13x minus sin 3x minus sin 12x minus sin 2x, and in the denominator this term of 4 sin 5x cos 5x, what we do is we'll write this as 2 into 2 sin 5x cos 5x. This frames the formula of 2 sin theta cos theta, and in the numerator I am restructuring the terms as sin 13x plus sin 12x minus sorry, I'll so we are clubbing the terms of sine 13x and sine 2x, so minus with the minus will become plus, and I'm clubbing the term of sine 12x with the sine 3x. The idea of choosing these two terms is that on addition they're giving me the same term of 15x upon 2 sine 5x plus, applying the formula of 2 sine theta cos theta, we'll write this as 2 sine of 10x. Now we'll apply the formula of sine c plus sine d in both the cases. The term would be 2 sine 15x by 2 cos 11x by 2 minus 2 sine 15x by 2 into cos 9x upon 2, the whole division by, I'm taking the 2 common, and this will be written as sine 10x plus sine 5x. In the next step, I'm applying the formula of sine c plus sine d in the denominator. Continuing, I am taking 2 sine 15x upon 2 common. In the numerator, I am left with cos of 11x upon 2 minus cos of 9x upon 2. In the denominator, after applying the formula of sine c plus sine b, I'll get this as 2 into 2 sine 15x upon 2 into cos 5x upon 2. 2 sine 15x by 2 and 2 sine 15x by 2 cancels. Now in the numerator, I am applying the formula of cos c minus cos d, which is minus 2 sine 5x into sine x upon 2, the whole division by 2 cos 5x upon 2. This 2 and this 2 will cancel off. Coming to this cos 5x by 2, I am applying the half angle formula on this sine 5x. I'll get it as minus 2 sine 5x by 2 cos 5x by 2 into sine x by 2, the whole division by cos of 5x by 2. I'm left with minus 2 sine 5x by 2 sine x by 2. Applying the formula of 2 sine a cos b, and I have a minus here, I can say that this is nothing but cos of 3x minus cos of 2x. My integral will simply convert to integral of cos 3x dx minus integral of cos 2x dx, which is equal to sine 3x upon 3 minus sine 2x upon 2 plus c, which is my option number A. Integral of 2x root of sine of x square minus root of sine x dx. We have been given the option in terms of some limits. Now to solve this, we need to know the identity that derivative of integral of f of t dt with the limits of a of x to b of x is nothing but f of b of x into b dash of x minus f of a of x into a dash of x. Using this rule, what we'll do is we'll take each and every option and try to fit with our solution. Trying with option A, that is derivative of integral of x of x square of root of sine t dt will be nothing but root of sine of x square into derivative of x square minus root of sine of x into derivative of x. Derivative of x square is 2x root of sine of x square minus derivative of x is 1, which is root of sine x, which we observe is our question. Therefore, our answer is option A. Integral of f of x g dash of x minus f dash of x g of x upon f of x g of x into log g of x minus log f of x dx. In the first step, I am going to split the term, so I get the integral as g dash of x upon g of x minus f dash of x upon f of x into log of g of x minus log of f of x dx. Substituting log g of x minus log f of x equal to t. When I differentiate, I get g dash of x upon g of x minus f dash of x upon f of x is equal to dt by dx, and therefore our integral will simply convert to integral of t dt, which is nothing but t squared upon 2 plus c, which is nothing but log of g of x minus log of f of x the whole square on 2 plus c. Now observe, we have no option which matches that which matches any of the a, b, c and d. So we'll simplify this. What we are doing simply is log of g of x minus log of f of x. What we'll do is will be written as log of g of x upon f of x the whole square upon 2 plus c. So this half comes out, becomes log of g of x upon f of x the whole square plus c. But we need it as f of x upon g of x. So what we do is we take that minus outside and make this as log of f of x upon g of x the whole square plus c, which matches with our option D. Integral of cos 2 theta log of cos theta plus sin theta upon cos theta minus sin theta d theta. We have the option as follows: cos theta minus sin theta the whole square log of this term, cos theta plus sin theta the whole square log of the same term, cos theta minus sin theta the whole square by 2 and the log of this entire term, and sin 2 theta by 2 log of tan pi by 4 plus theta minus half log mod sec 2 theta plus c. At the very first step, we would just concentrate on cos theta plus sin theta upon cos theta minus sin theta, which we know is nothing but the expansion of tan pi by 4 plus theta. Also, please note, we know that integral of sec theta d theta is equal to log mod tan pi by 4 plus theta by 2. Taking this idea further, integral of sec 2 theta d theta would be log mod tan of pi by 4 plus theta. Using this idea of integral of sec 2 theta, therefore we can claim that 2 sec 2 theta is nothing but derivative of log mod tan pi by 4 plus theta. Now coming to our original question, I am writing this as log of cos theta plus sin theta upon cos theta minus sin theta. We'll write this term first and cos 2 theta later. We will be applying u into v as our formula. So this becomes u log of cos theta plus sin theta upon cos theta minus sin theta, integral of cos 2 theta, which is sin 2 theta upon 2, minus integral of the derivative of log of cos theta plus sin theta. We have already derived that as 2 sec 2 theta, and the integral of cos 2 theta would be sin 2 theta upon 2 d theta. Writing the first term as log of tan pi by 4 plus theta into sin 2 theta by 2 minus integral of tan 2 theta d theta. Sin 2 theta into sec 2 theta is tan 2 theta. This will generate an integral of 1 by 2 log mod sec 2 theta plus c with the term as log tan pi by 4 plus theta into sin 2 theta upon 2, which is nothing but our option D. Integral of x sin x sec cube x. Our options: half sec square x minus tan x plus c, half x sec square x minus tan x plus c, half x sec square x plus tan x plus c, half sec square x plus tan x plus c. Now what we do in this sum is write this as x sin x and write this as 1 upon cos cube x dx. We'll make one term as tan and the remaining term as sec square x dx. And we'll apply u into v, but in a manner where I'm going to write this as x sec x into sec x tan x dx. Now what am I doing is I'm saying that this is my u and this entirely is my v. Applying the integral, it becomes x integral of sec x into sec x tan x dx minus integral of the same thing, which is sec x of sec x tan x dx. Now observe the reason behind writing it in this form is like the derivative of sec x is sec x tan x dx. So I can clearly claim that my answer is x into integral of t, which will generate the answer as t square upon 2 minus integral of the same thing sec square x by 2 dx, because this would be the integral of cut. We'll now apply u into v over here. It will be equal to u integral of sec x into sec x tan x. काटना है इसको. We'll now apply u into v. This will become x integral of sec x of sec x tan x minus integral of the derivative of x, which is 1, and integral of sec x tan x dx. Now the advantage of writing it like this is that I have the term, that is if sec x is t, the sec x tan x dx becomes my dt, and I can directly write this as x sec square x upon 2 minus integral of sec square x upon 2 dx. So my answer is x sec square x by 2 minus 1 by 2 outside, integration of sec square x dx, which is nothing but x sec square x by 2 minus tan x by 2 plus c, which matches with our option B.